It involves adding and subtracting polynomials. First of all, let's make sure we understand what a monomial is. The book's definition is simply an expression that has a number, a variable, or a product of numbers and variables. Okay? So you can say to yourself, what's a monomial? Well, a number. Okay? A number is a monomial. A variable is a monomial. A number combined with a variable or variables. Okay? All of those things are monomials. Mono meaning singular, and omial, singular thing, singular name thing. Okay? Now, poly means multiple. Okay? Poly means multiple. So if you add all of this together, like this, you have a polynomial. Okay? This is a polynomial. It is the sum of a bunch of monomials. Clearly, I wouldn't leave this like this. I would collect my x's, and I would end up with 2 plus 7x plus 6xy. Now remember, I just made that polynomial up. It's not in your book. So this is the simplified polynomial form, the simplified polynomial of that. All right? Now, when a number is just a number, this is still a monomial, but this monomial is what's called a constant. Okay? The reason it's called a constant is because 2 is always 2, or if it were 5. 5 is always 5. There's never an argument as to what that number means. Okay? That is a constant. In contrast, oftentimes you'll hear me refer to something like this. This monomial is what I call a variable. Okay? The reason for that is the value of this is based on what x is. So 7 times x, well, what if x is 1? Then the value of this is 7, right? But what if x is 2? The value of this becomes what? 14. Okay? So it's very important that you recognize that 2 has a constant value, therefore it's a constant. 7x and 6xy, for that matter, is a variable because it varies based on what the values of the variables are. Okay?
Katie Lynn, to the office, please. Katie Lynn.
Now, polynomials can be binomial, meaning 2-termed, or trinomial, meaning 3-termed. Okay? This one up here, after I simplified it, was a trinomial. Okay? Binomial, x squared plus 2, there are 2 terms. There is a variable and there is a constant. Trinomial, there are 3 terms, variables and a constant. Okay? We don't go any further than that, naming them like quadrinomial, pentanomial. You don't do that. So it's a monomial if it's 1, bi if it's 2, tri if it's 3, poly if it's just anything over 1. Okay? You'll hear me use these terms. Some teachers don't, but I do. Binomial and trinomial. Okay? Now, the number that precedes the variable is called the coefficient, and it drives how many of the x's there are, how many of the variables there are. Okay? So this means literally there are 4 x's. Okay? The one up here, there are 7 x's. okay? The coefficient drives how many variables there are. Now, an item is in simplest form, like we did here, when all of the like terms in the polynomial have been collected, okay, grouped together. I cannot simplify this any further because I cannot combine a number with a variable with a different variable, okay? You might say to yourself, Mrs. Myers, can't we add 7x to 6xy and make it 13xy? No, because this is just 7x. 7x is one type of thing. 6xy is another type of thing, okay? For practice, we're going to simplify in example 1 a nice long polynomial that has several different terms that are all kind of different types. Our job is to combine ones that are similar. Negative 6x cubed, 3x squared, x squared, 6x cubed, and negative 5. Okay. The standard way of doing this is to work from the largest exponent down, which means I am going to work from my x cubes down. A negative 6x cubed combined with a positive x cubed is what? 0. So for all intents and purposes, they cancel themselves out. I'm not going to write anything. The book writes 0x cubed. The next variable that we're going to deal with is the x squareds. 3x squared, and this one has no coefficient, which means it's a coefficient of 1. 3x squared and 1x squared, 4x squared, right? Crossing them off. Is there anything for me to combine my constant with? No. This is the simplified form of the above polynomial. So this binomial is the simplified form, okay? Just something to note, when you're dealing with multiple variables and multiple types of variables, I always list them from the largest exponent down, and then I try to also do alphabetically if possible. Okay, so like if there's x's, xy's, y's, y squareds, I would take something like this. I would take something like this, and when I simplify it, start with my x cubes, then do my x squareds, and then do my xy, and then the number, okay? So just for practice, positive 2, negative 4, looks like a negative 2x cubed there, okay? I hope you're copying this. A positive x squared and a positive 3x squared is a positive 4x squared. Negative xy has nothing to combine it with. This is a variable, this is a constant. Negative xy, positive 2. Okay, so even though it's big and messy, you can combine it and simplify it, and it doesn't become a trinomial or a binomial, it is just a polynomial, okay, because there are more than three pieces. All right, write the sum of the areas of the rectangles as a polynomial in simplest form. This is example 2. And they draw several rectangles. Let's look at the blue one. What is the area of the blue one? The blue triangle, blue square that's in your book on page 146. He says it's 3x times x. Very good. Which is 3x squared. 3x x times x is 3x squared. That is rectangle A. Let's do rectangle B. 2 times x. Ben, what's 2 times x? Nope, 2 times x. 2x. Good. And how about C? 3 times 3x, Kens? 9. X times x is x squared.
There is no 2x though.
B is not 2 times x? I'm pretty sure B is 2 times x.
We already did B. We already did B. We're doing C. So.
I know that, so that's 9x squared, right?
No, it's just 9x.
3 times 3x. Okay, sorry. All right, moving on. D, 3 times 2 is? Good. Okay, now, is there anything that can be combined here?
Yes.
The x's. Yep. X squares can't play at this party because they're not x's. 3x squared plus 11x plus 6 is the final simplified version of the sum of the areas. Okay? All we did was find the area of each shape, we added it together and simplified it, and that's what we ended up with. Okay? Now, degree of a variable in a monomial. Okay? So we're going to learn about degrees. First, of a particular variable in a monomial. Okay? So let's just say I give you some degrees or some things. Let's say I give you okay, the degree is driven by the exponent. Okay? 6 has a degree of 4. 6x to the 4th. Y has a degree of 2. Z has a degree of 3. So it is the exponent that tells you what the degree of a single monomial is. Okay, so I found this one, I found that one, and I found that one. Okay? What if I asked you, what is the degree of that? 0. 0. I know, this is a weird thing. Any non-zero number has a degree of 0. Okay, this is a fact that you'll need. It's not a fact that you need to love. It's just a fact you're going to need. Okay? All right. Let's go to example 3. In example 3, we're gonna do another degree of a monomial, and the monomial is 5x squared yz4. 5x squared yz4. Holy cow, that's a lot of stuff. Okay, which one do we pick? The z, the x, the y? Well, you find the degree of each thing. Okay, 5 is a 0. X squared is a 2. What's y? 1, because it's y. Y to the first. Okay, and z is 4. Add all of that together, and you find that this polynomial has a degree of 7. Okay, the degree of that monomial is 7. Okay, now, that's degrees of a monomial. How about, yes ma'am, how about of a polynomial? Okay, 6x squared plus 2x plus 3. Okay, 6x squared plus 2x plus 3.